Let's do some math. Today we're doing 2.5, 2.6. On Wednesday, we are going to do 2.7 and 2.8. They'll finish the stuff before the midterm. At that day, I will release the midterm for you. I will post a video review or video solution to how to do everything. But you'll have a blank exam that you can give a practice run on. Our midterm will be not this Wednesday, but next Wednesday. Also on Wednesday this week, the dean is coming in. He is helping me evaluate, helping me try to be a better teacher. So every few years we do a voluntary self-evaluation, and he collects feedback from students that he can give to me anonymously rather than being like asking students who aren't going to tell me in my face that I suck. They'll tell me, so he'll give you information. You should have something in your email that's asking you to complete a survey. Please do that. It's anonymous. I won't know who typed what. It gets back to me like how I can make this class better, and stuff like that. So
supposed to say that you mentioned.
What?
They mentioned something was supposed to say.
That's him, the dean. He'll be in here on Wednesday. You're gonna watch how I lecture for a little while, watch how I make fun of my students, and just be all around a rat bastard teacher. But until then, you're mine. Some ominous bit right there. 2.5 is on equations of lines and linear models. And line has the word, or linear, and has the word line in it. We're doing straight lines. So there's a couple ways there's a couple forms for it. The standard form is called is ax plus by equals c. And there's no fractions in it. So you've cleared the fractions. That's standard form. I don't know that it's all that helpful, but it's a way that sometimes they come in. There's the point slope form, which we're going to work with first. This is y minus y1 equals m times x minus x1. For this, you need m and any one point. This equation comes from the equation for the slope. You clear the fraction. And relabel x2, y2 as xy. Oh, that's
Just y, not y too much.
but
So
y minus y1 equals m times x minus xy. That's the point slope one. And what Luis has been super excited for, he wanted to get to it last week. It's called the slope intercept form. One of my personal favorites. It's easiest to graph from. Y equals mx plus b. M is your slope, just like before. B is your y-intercept. So 0, comma b. Maybe I'll make it a capital B so it doesn't look like a 6. And this is just solve either of the above. Or y. It's really easy to come up with, but you have to have. Well, you don't need to have the equation. This is easiest to work with. To create, I should say. If you have M and the y-intercept. It's actually a little more work. Than the point slope form. Or any other point. So let's get to it. Let's start with the point slope form. Using the point slope form. Write an equation. For the line. Passing through. 3, -5. Having a slope of -2. So we're using y minus y1 equals m times x minus x1. This is my m equals -2. This is my x1, y1. So x1 equals 3 and y1 equals -5. Got y minus y1 equals m times x minus x1. We're just going to replace those three things, m, y1, and x1, with those values. y1 is -5. M is -2. And x1 is 3. We do that, we can clean it up a little bit. This is y plus 5. And this is -2 times x is -2x. And -2 times -3 is +6. Now from here, we got 2 paths we can go. Solve for y. And we get slope intercept form. And we're going to do that because we're going to do the points or slope intercept form on this one in a second. And we get y equals -2x plus 1. So this is the point slope form. And this is the slope intercept. And if we wanted to write it in standard form. We add 2x to both sides. We get 2x plus y equals 1, and this is standard form. Standard form, this is the ax plus by equals c. Standard form usually has a as positive. Which is what we have here. We don't want to have a negative in the front, it just reads bad. So that form, and we get that form. 3 forms for the same line. Let's get that same equation using the slope intercept form. We still have our same information, m equals -2. And we have x1 equals 3. And y1 equals -5. Maybe I should pause, make sure everyone's done with the other part. The lights went down up there.
Power went out this one for a few seconds.
Everyone ready? Let's see if I'm really ready. Are you ready? So we have y equals mx plus b. We have a y, an x, and an m. So let's plug those in. Y equals -5, m equals -2, x equals 3, plus b. So -5 equals -6 plus b. I add 6 to both sides, I get 1 equals b. That's not where you stop though. That part is actually pretty easy. A lot of times students forget to put it back in. We need to take m and put it in there. And we need to take b and put it in there. And we get y equals -2x plus 1. And you'll see that we got that up here. So in this one, you have to solve for b first. Then plug it back in. Which both methods will get you the answer though. I'm not looking forward to Friday. I got a wisdom tooth extraction. Both upper ones. I only really need one. This one, it's cracked and it hurts. This one doesn't do nothing. I don't know how the fuck I cracked it. I don't remember biting on anything and fucking feeling my tooth just fucking shatter. But it's that, it's got a sharp fucking ridge on it. It's like a big old chunks like missing from it. I don't have a lot of cavities, I don't know what. Like I fucking bit down on a rock or something. And lost. Alright, you guys ready for some more? We get points. -4, 3, and 5, -1. Let's do the same thing. Find the equation. We'll do point slope form and slope intercept. Both forms require a point and M. So what can we do? We don't have that, do we? We have a point, we have 2 points. Can we get M?
Yeah.
So let's use the points to find M. We're calling that it's y2 minus y1 over x2 minus x1. Take a second and figure that out, see what you get. The equation already? Let's make sure everyone's at the same step first. We do -1 and 5 and 3 and -4. And we get -4, ooh, ew. Ew.
So.
No,
So now you have to think.
-4 over 9. They're both squares, but we can't take the square root. What the fuck am I doing? That is not it. Fucking rushing through it. Wait, yeah, it was. Wait, no, that was -4 down there. So I've got, yeah, there's something off. -1 minus 3 is -4. No, I had it right.
Yeah.
Fuck. Tripping out. Alright, so go through and now do the point slope form. and slope intercept form. And you can use whichever point you like. Both points will yield, eventually get you there. None of them are gonna be friendly. What you guys do? Finished, Jimmy? Did you? Keep going. Just because Eric's done doesn't mean. You giving up on me? Are you quitting? You got it then? What'd you get? Yeah, just like that. You can do me like that, Jimmy? All right, I'll throw Luis under the bus. Luis, what'd you get? What? The final question. You should get the same thing for both, so yeah. Oh, okay. So,
Fractions.
what'd you get? What were your two forms? Let's see which one was right.
Well, y minus y1 equals x, I see, but are you wanting like y minus 3
Okay, you went with that one. Okay, that'll work.
equals -4/9 in parentheses x just -4.
All right. So. I'll do the hard part. I'll turn that into a +4. And now you guys do the easy part and distribute. It's fucking hella easy.
What is
After the 4.
-4 nines x plus -4 nines times 4 is just -16/9 on that one.
Yeah.
That wasn't fucking. Now granted, that turning the x minus -4 was definitely the easier one. I was making a joke there. But this one wasn't hard, the multiplication wasn't hard. It's just ugly.
I got that. I got that too. That's where I stopped though.
So when we add 3 to both sides. We can't really add 3 as is, can we? What can we do about that?
so over 9?
Make it 27/9, how'd you do that?
9 goes into 27 3 times.
Or multiply by 9/9? That'll get the same thing, yes. I like how you're doing it, even better. The quick way is just to multiply by the common denominator. Get a common denominator, multiply by it. So we've got, and we added the 3 already, so this is y. 27 minus 16 is 11.
Oh yeah. I think so. You're talking like
Fuck with me. It's like I was already second guessing myself. All right. Did you get that in either form, anywhere?
fuck no.
But no.
I got a whole ass like number. I didn't get a fraction. Instead of because you know
Do you have like a 9y on the other side? Because we could have, you could have this with no fraction. We multiply through by 9.
Yeah, I stopped right there because I went after I stopped at the point slope, I went straight to like slope intercept learn. But instead of 27/3, I would have just done 9 times. Yeah.
So you cleared the fractions.
Okay.
That's actually a valid method here. So like, let's rewind this and do this. Rather than adding 3, let's clear the fractions by multiplying by 9. So I'll have 9 times that side and 9 times this side. This is what I'm saying to do. If you don't like working with the fractions, don't. It requires more work, but we can avoid the fractions. This becomes 9y minus 27 equals -4x minus 16.
I see what.
You didn't do the times of 3, did you?
No. I did the. So when I multiplied each side by 9, I multiplied 9 times 16, and I got 144. Instead of just
Instead of just clearing the 9.
yeah.
So then we add 27 to both sides and get 9y equals -4x plus 11. Now we divide by 9. And we get that, and we avoided having to do this fraction addition. In fact, we could have done that all the way up here. Multiplied by 9 up here. And you get 9y minus 27 equals -4 times x plus 4. And you distribute it, you'll eventually get there.
But from the y equals -4/9, you can divide that by 9 and get 9y equals -4. X plus 11.
Say that again?
You can go from y equals -4/9x to 9y equals 4x plus 11. I divide it by 9.
Yeah,
Should do that.
yeah, here we had this line. And then we divided everything by 9 to get rid of the 9. Let's take a look at the point slope form, or doing the same thing with the slope intercept method. Y equals mx plus b. I'm gonna use the -4, 3 here. 3 equals -4/9 times -4 plus b. I don't know that multiplying by the 9 is any, well, I guess we could. I mean, if you multiply by the 9, you get 9 times 3 equals 9 times -4/9 times -4 plus 9. This is 27. We gotta distribute here, that goes to -4 times -4 plus 9b. I think it's easier just to get a common denominator right away. Here you would have 27 equals 16 plus 9b. Subtract the 16. We get 11 equals 9b. And divide by the 9, and we get b equals 11/9. Or get a common denominator here by multiplying by 9. That's positive 16. Subtract. And you're just subtracting numerators. And you get 11/9 again. In both forms, you don't stop. Now that you have b, you gotta plug it into the big equation. Was that done? Is that everything you hoped it would be, and maybe just a teensy bit more? A poquito?
It's wrong word.
The fuck you, it's the right word. We went over this last week. Fucking busted my balls last week or Monday on this. Poquito was a little bit. Fucking remember. Fucking learn. Adapt. Find the slope intercept form. Uh, 3x minus 4y equals 12. Try to troll me. Kudos to Luis for saying he didn't have the right answer and going with it. Now, I wonder If he hadn't given you shit over the last couple weeks, if he would have fucking said anything. Cause here he had to represent, I asked you, you didn't answer, so he had to try to one up you by answering, even if it was, I don't have a good answer. Would he have done that if there was no shit talk over the last month? I don't know. I don't know. How much of that was fuck you, Jimmy, and how much of that was like wanting to answer the question? I don't know. Only Luis knows. And he may not even know it, maybe he just a subconscious thing. Maybe he fucking he's got Jimmy haircut and
I just have to reflect the question.
controlling. Alright. What do I do? Now. The fuck are you smiling about, Luis?
I was about to say, take it away, Jimmy.
You don't need to be a dick. That's my job. So what do I get here? Now I divided the right side by -4, but remember that breaks up into dividing each of them by -4.
Negative 4x.
What do I get?
4x.
I thought you said negative in there, I was gonna.
The negative 3.
-3.
Excellent. Teamwork, teamwork, teamwork. Alright, so that was fun. Right? What about vertical lines and horizontal lines? What's the slope? For a horizontal line? If it will help you, I'll give you 2 points. 1, 3, and 7, 3. 0. I don't know who said that. We have 3 minus 3 over 7 minus 1. 0 over 6 is 0. It's a rise over a run, and there's no rise. No rise over a run. So y equals mx plus b turns into y equals b. For the points I just gave right there, y equals 3. That would be the equation of that line, since we have a 0 slope. What about vertical line? One, 3, and 1, 7. What does this mean? It doesn't exist, why?
0 and
We say the slope is undefined. And the slope, the line really doesn't care what y is. The only defining trait of it is. X equals 1. So that would be the equation. Vertical line. All right, so next topic. Parallel lines and perpendicular lines. Perpendicular. What does parallel mean?
Come across each other.
They don't cross each other. Which means they go in the same direction, but they don't overlap. What is
Squared. 2, 5, 6.
What, Tara?
Oh. My bad, I forgot that my microphone was.
She turned it off, so she doesn't have a question. All right, perpendicular, what is perpendicular? They cross. Do they cross like that?
90 degrees. 90 degrees.
90 degrees. Oh, he's coming out with some trig shit, some geometry shit. Those are perpendicular lines. Our XY axes are perpendicular. They don't have to cross like that. One could be at a diagonal, and as long as when you rotate it, each of these, you could make a box and it would actually look like a fucking box. It wouldn't look like a rhombus or some fucking diamond. Well, I guess a diamond does look like a box. It wouldn't look fucked up. So the symbol for parallel is this. That's the symbolic version for parallel. And the symbolic version for perpendicular is that. They don't make it like the full cross thing, because the full cross thing looks like a plus sign. That's confusing. They don't make it look like a fucking T, because, well, T's a letter. That's just how they do the perpendicular sign. So what's fun about lines is if M equals F over G, just some numbers. Parallel lines have the same slope. So I'm gonna say the blue line here. The blue line has a slope of F over G. My red lines here will also have a slope of F over G. For the parallel or the perpendicular line, if I have a blue line like that, and I have the perpendicular line to go with it, the slope of the perpendicular line is the negative reciprocal. So we flip it over, we make it G over F, and we make it negative. And this, you tend to deal with this as long as they're not vertical lines. Or you won't find a perpendicular line for a horizontal line. I guess you could, but you need to know through where. So what we're gonna do now. You guys need a break? Let's take a 5-minute break. He's walking out right when I'm gonna go over something that I know will be on the exam, so. Let's take a 5-minute break. So I just wrote a quick recap. Of what we had before. We're gonna use this information. So. Find a line. That is. A parallel. To 2x plus 5y equals 4. And passes through. 2 -4. And then B will do perpendicular with the same information. Alright, so. First thing we need to do is find the slope. We need the slope of this line. To find both of those other lines. So if we subtract 2x from both sides, we get 5y equals -2x plus 4. We divide by 5. And we get y equals -2/5 x plus 4/5. This is the only thing we care about from that piece. That's m. We can scrap the rest of the equation. Students notoriously like to try to use that shit in the next part, and it doesn't work. So, once we have that information, now we can go through and do parallel and perpendicular. Parallel has the same slope. So m here will be -2/5. And the perpendicular m will equal +5/2. In both cases, we're using the point 2, -4. Neither of them is the y-intercept, so I think y minus y1 is the easier form here. The point slope form. We got y minus -4. It's gonna be the same setup on both sides, y minus -4. This one has -2/5 times x minus 2. This one has 5/2 times x minus 2. So this is y plus 4. If I distribute, I have -2/5 x plus 4/5. I subtract 4, I wanna get a common denominator, I'll multiply it by 5/5. Which means this will be -20/5 on this side. And I get y equals -2/5 x. And 4 minus 20 is -16. So -16/5. Over here. I'll let you guys finish it. Some practicing. Like this shit's easy. Not too bad. Just like following instructions. You can put something together from IKEA, you fucking do algebra. All right. But I think following the instructions from putting together something from there is actually harder than most shit in algebra. Like, what? I don't even have that fucking thing. Wait, is that what I plugged in over there? Oh shit, use the wrong thing. End up with fucking leftover pieces. That's the fucking best. You're like, was it extra or am I missing something somewhere? Because sometimes they include spares in case you lose it. You never know unless you count them all ahead of time. And no one does that. You only end up with spares and you're like, fuck. Alright, so if we distribute here, this is kind of flat out straightforward. 5/2 times 2, the 2's cancel. And you're left with 5/2 x minus 5. So when you subtract 4 here, there's no extra work. Now that's how I want to go down the hall. That's some baller shit right there. Just fucking choo fucking. All right, you guys ready for 2.6? Anyone need this up longer? Josue, are you good?
Yeah, I'm ready. I'm ready.
He's a lurker. I know he's a lurker. I gotta ask these things.
I'm ready.
So graph's a basic function. Your basic. Interestingly enough, they decide to list what continuity is in here. Continuity. I don't know why it's needed in this section, but they have it. A function is continuous. Over its domain. If a hand-drawn graph. This is not like a real definition, but it's a practical definition. If a hand-drawn graph can be made. Without lifting the pen. Or pencil. Off of the paper. The red line is continuous. The green line is not. Okay, so this is for a little bit more on what we're doing here. 2.6 is gonna have just like basic functions with nothing multiplied by them, nothing added to them, nothing subtracted, nothing divided. It's just the basic graph. Because when we do, it's either 2.7 or 2.8, you will see that like multiplying by them does similar shit for all the graphs. Adding something to them does similar shit for all the graphs. So once you've learned and mastered the shape of the basic graph, learning how to do the multiplication and adding and subtracting shit just means modifying that beginning basic graph. Okay? It's more like pimping out your car. You gotta know how the car works before you pimp it out. Right? Throw some nitrous in there. Fucking fine leather seats. Fucking racing stripes, some ghost flames. Alright, so our most basic graph. F of x equals x. This graph is called the identity. Which is stupid. It's because y equals x. When we get rid of f of x, y equals x. If you made an XY table. I'm gonna do this -2, -1, 0, 1, and 2 for all of the graphs. The y value is the same here. It has a domain and range. Negative infinity to infinity. Or you can say all real numbers. Same thing. It is increasing everywhere. And and continuous. Ready for more? So that was y equals x to the third power. Does anyone need it up longer? This way.
No, I'm ready. I'm ready.
Alright. So our next one is the squaring function. F of x equals x squared. You are really just taking the x values and squaring them. -2 becomes 4, -1 becomes 1, 0 is 0, 1 is 1, and 2 is 4. That does not look like a perpendicular. Let's straighten that bad boy out a little bit. With a really, really super thick y-axis. Fuck off. It's better. Wanna do this? Alright, so if we plot these. It's a curve. You want it to be curved at the bottom. It's not pointy. It's a curve. So a handy way of remembering this is right 1, up 1. Right 2, up 4. Or you can do left or right 1. The domain here is all real numbers. The range is restricted though. The lowest value is 0. So this is 0 in a bracket to infinity. It's decreasing from negative infinity to 0 and increasing from 0 to infinity. And it's continuous everywhere. Cubic function. F of x equals x cubed. So when we graph this bad boy. -2, -8 is way down here. -1, 1 is there. 0, 0 is the origin. And we do something similar over on the right. None of that. Now. So it's kind of like it looks like a parabola, but it's steeper parabola on the right. And then it's like an upside down parabola on the left. Domain and range are both real numbers. And it is increasing and continuous everywhere. I even want to show you one of these. I want to show you it, but I don't want to have any problems in your homework because it's fucking lame. Ready for the next one? So we did the squaring function, here we're gonna do the square root function. F of x equals square root of x. Now here, we can't graph complex numbers, so x has to start at 0. I'll still do 5 numbers though. But since we're taking the square root, this works a lot better if I just list square numbers. So the square root is 0, 1, 2, 3, and 4. All right, so the domain and range for this graph are both 0 in bracket to infinity. There's no negatives for any of them. It is continuous. And increasing on 0 to infinity. But don't include 0. Notice I don't have the bracket here. We don't say it's continuous there because it doesn't have anything to the left. It starts there, so we don't really say it's continuous because it stops. In fact, I'm fucking yawning now too, thanks Jimmy. You'll notice if you rotate this, it looks just like x squared. Square root and x squared look like rotations of each other, although it's missing the other side. We'll discuss why that's the case later on. There is a reason for it. It's going to be even more noticeable with the cube root function. We want to plug in numbers that are perfect cubes. -8, -2 is right there. -2 is right there. So. Domain range. Again, all real numbers. And it is increasing and continuous everywhere. Ready for more? This is not the most exciting section. You're learning the basic graphs, it's worth practicing them. You do not need to memorize these tables. You can always calculate them. You're just taking your x value and plugging them in on all of them. For the square root and the cube root, I think it's easier to do the y's and do the opposite operation, like square them going left to find the numbers. That way you're not having to memorize more shit. All right, next function is a fun one. It's the absolute value function. F of x equals the absolute value of x. Which means it equals x if x is greater than or equal to 0. And it equals negative x if x is less than 0. Good. Thank you. So if we make an XY table. It doesn't matter what I plug in when I take the absolute value, it's positive. This does make a corner. called a cusp. It's pointy. So the domain is all the possible x values, the domain is all real numbers, all possible x values, just as a reminder. It's been a couple days since we did it, and I didn't actually re-say it. Range is all possible y values. And the range can't be negative here. The output is all positive, so it's 0 to infinity. It is decreasing from negative infinity to 0. Increasing from 0 to infinity. And it's continuous everywhere. All right, so this is an example of a piecewise function. Piecewise functions have more than one part. Absolute value is just an example. So piecewise functions can be anything. Let's take a look at graphing one real quick. Let's say we have f of x equals 2x plus 4 if x is less than 1. And 4 minus x if x is greater than or equal to 1. And this is negative x plus 4, which might be easier to graph if we write it like that. So one way of doing it is I would recommend using like a pencil first, making it light. Do both lines completely. I'm going to do dots. I think it's better if you have dots. So 2x plus 4 crosses here And it's got a rise of 2 and overrun of 1. So this is doing this. My other one, negative x plus 4, starts here, and its slope is -1, so down 1 over 1. So this was the 4 minus x, and this is the 2x plus 4. Now the 2x plus, I mean, I'll wait for you guys to have that graph, 'cause once you have that, gets pretty easy after this. Alright, so 2x plus 4 is only valid when x is less than 1. X is less than 1 is right here. So it's valid, 2x plus 4 is valid for values less than 1. And when I get up to the 1, it does not have the equal portion, so I'm gonna put a circle at 1. So I'll have a circle like that. This line basically starts at 1, it's for 1 and larger. And it has the equal portion. Have a good weekend. Or
Weekend.
what, Monday, it's fucking Monday, isn't it? I don't know what day it is. Starts at 1, and we have a solid point here because it has the equal sign. So this is doable without the dotted lines, but you have to kind of be paying attention. Make sure you're doing the right ones. We'll do more examples of that one. In Math 335 next week, or on Wednesday, shit, still doing it. There is another function I need to show you. It's called the greatest integer function. This function sucks, it fucking blows. And I was thinking about not even doing it, but someone's already done the homework and looked at these. So it looks like this. They do some weird like double bracket shit. What it does is f of x rounds down to the nearest whole number. So like 0, 0.1, 0.5, 0.7, 0.99, these all have a y value of 0. It rounds them down. It basically drops the decimal. But that doesn't last as soon as you start doing the modifiers. Then we go to 1 and all of a sudden 1 is now a whole number, so it rounded down as 1. And we could have 1.01 all the way up to 1.99. These are all ones. 2 up to 2.99 is 2. The way this graph looks. Where it starts is a solid point and it goes till the next one and becomes hollow. Solid, hollow. Solid, hollow. We go the other way too. Looks like steps. So I'm going to show you a variant because this is the one section that we're like, we don't do the function, the greatest function later, integer function later on. So we're going to show you a little bit of scaling and how it works right now for this one. So if we have f of x equals like 1/2 x plus 1. So easiest way to look at this is look at like what the whole numbers do. So like let's do like -1, 0, 1, 2, 3, 4, and we can fill in the gaps between it. If I stick in -1, I got -1/2 plus 1 is -1/2. If I stick in 0, I get 1. If I stick in 1, I get 1.5. 0.5. If I stick in 2, 1/2 times 2 is 1, plus 1 is 2. Looks like these are increasing by 0.5 as I go along. So it looks like 0 to 2 is the full amount of time it takes to go from 1 to 2. So I'm at 0, 1, I got a point here, and it takes going all the way up to 2 before I hit the circle, and it increases. And here 2, 2 is up here. And it's got to go all the way up to 4 before it stops and hits the circle. And you're gonna see this pattern is the same, it's going two along. So the length of each bar is the reciprocal of the slope. M equals 1/2. Bar length is 2. If M equals 4/3, the bar length is 3/4. And compared to the original greatest integer function, this shows how far up and down from the base graph. The base graph started at 0, 0. This one moves up 1 and it starts at 0, 1. Did you guys see that? +1 means we moved up 1. If it was 1/2 x minus 3, it would go down 3 and go over 2. So the length of the bar is the upside down, and then how far up or down that base graph starts is whatever this is. Go up and down from the y-axis from there. And that's it for now. It's 6 o'clock. Or 5 o'clock, whatever. What time is it? I don't even know. I'm gonna go through, if someone emails me, reminds me, someone email me. And say, give full credit on all the greatest integer function problems. Because you won't use this. I don't know where you fucking use this, I don't even know why it's a function. I don't know what purpose this fucking function serves. But I can't delete it from the homework because someone's already started the homework. So I can't go through and just give full credit on these problems. On the greatest integer problem, that's what I'm gonna, not the whole section, but the greatest integer problems. Have a good evening, I'll see you guys Wednesday.
Have a good day.
Good day to you, sir, good day.